study began. And as we said, when we talk about prevalence and incidence, prevalence is really about existing cases of the condition. So the population size is given, and then existing cases of myositis are also given on the same day. So I think that is straightforward. So how many were those with myositis? 15? Divided by 500. So that is, I think that is the number. Yeah, 15 existing cases of myositis were treated on January 1. So N is 500. Then the existing cases were 15. So that is prevalent. Now, cumulative incidence rate of clots in the breeding age female. Again, the cases of clots. How many cases were there? Is it 45? How many cases of blood? How many are there? 45 cases of blood, yes, during the year. So we have 45. That is our numerator. Then what is our denominator? Again, it is during the year. So we have to average out the population. Again, it is in breeding age female or cows. So we limit ourselves to that 500 number. Let me put it this way. 500, then plus, then the rest, what the data present there. Says 28 cows were purchased into the, and then 90 young heifer reached breeding age during the year. So you include this one. 28 cows were purchased. You also include this one. 65 cows were sold. You also take note of this. And then finally, there are 30 cows died during the year. So these are the transaction or the change in the number during the year. So basically, I start with 90 breeding age females, 28 purchased, then minus 65 that were sold, and also minus 30 that died. So you divide this section by 2, then that will give you the average. So this should be operated first before dividing it. So this is your number for denominator. So in all others, like cause-specific mortality rate of blood in breeding age female, you use the same denominator for that one. Proportional or not for proportional. So whenever you are talking about denominator for the year, and in breeding age female, you always use that figure. Yep.
Okay, so last time we did cumulative incidence rate, it was between the starting population, and then we did 30, and then we divided between those two numbers. I'm just a little confused as far as how you want us to do average.
It really doesn't matter. You can put this 500 represent all of this. You can put 500 here, 500 here, also 500 minus this, 500 minus this, and then divide all by this number, 1, 2, 3, 4. So divide that one by 4. And then it will be the same. Okay, me, I am just looking at only this section, the changes that occurred during the year, and these were not there from the beginning, so I divide this one by 2. So the way I look at it is what? Population at the beginning and population at the end. Because it's cumulative, I'm not looking at the change that occurred during the middle of the year. If you want to look at that one, it will be, that is even more precise if you want to do that. But for us, it's cumulative. It's cumulative, you look at what? At the beginning and at the end. That's the way I did it here. So population at the beginning plus population at the end divided by 2. The cause-specific mortality rate of blood in breeding age females. What was the cause? What is the mortality here from blood?
15.
It's 15. Okay.
15 died.
15 died. And again, what is the denominator? Cause-specific mortality. It's what? Death from a given disease.
Total
in
mortality.
average population, yeah.
Female.
So you still
Female
use
blood.
average population for this. You use the same denominator here for the specific mortality rate. Abortion rate, again, this one you have to know your population at risk. It's again defining your population at risk. So when we talk about abortion, again, it has to be a female in the first place, and then pregnancy has to be confirmed. So your denominator will do what? Those bred female in which pregnancy has been confirmed. So how many aborted within the year? How many aborted?
50.
387 glass? No. Yeah, 543, 40 cows, 540 cows and heifers were bred, of which 37 were never found pregnant. So these 37, although they were bred, because they were never found pregnant, so they are not at risk of abortion. So you don't include them. So it's 540 minus 37. So 50 cows aborted. So your numerator will be 50 divided by 540 minus 37. So that is your denominator.
Dr. DePablo?
Yes?
Sorry, can I take you back to B? The 500, okay, the 90 plus 28 minus 65 minus 30, those are 4 different populations, so why don't you, rather those are 4 different groups of individuals at risk, so why wouldn't you be dividing, so like if you did 590 plus 528 minus, in the chunks and then divide it by 4
So,
instead of divide by 2.
This one, I'm really not looking at them as separate. What, as I said, what I'm looking at is at 2 populations. Population at the beginning that I have, okay, then population at the end. So these were not there at the beginning,
Yeah.
so I assume they will be there at the end, okay? These were not there at the beginning, I assume they will be there at the end. These were there at the beginning, I assume they will not be there. These were not there. So what I'm trying to do is what? Population at the beginning, and then I can put 500 here if I want. Okay? I can put 500 and then divide the whole by 2. So I'm looking at just 2 sections, the beginning and at the end. So here what I'm trying to do is what? I put, the way I'm looking at it is what? It's not like 4 populations. This is just one group. But I didn't put 500 here. Because if I put 500 here and divide everything by 2, I still have 1,500. So that's what I'm removing.
So when I ask you in the class,
No,
okay, sure. I'm sorry.
Continue.
Well, I mean, you can take her question because I'm still trying to formulate my question in my
Okay.
head.
When I ask you in the class, I think when you want to make average, either you can do this way or you can multiply 500 with each of them, and then you can do total number, or if there are 4 number in the numerator, you can divide by 4. Or you can add it and then you can divide by 2. For example, 500 plus 90 and 500 plus 28, 500 minus 50, 65, 500 minus 30. Divided by 4 and then it will be the same
that
answer.
You can do that. Then in that case, still you have to know that you can put 590 here, 529,
Exactly.
560 minus this,
Over 4.
500 minus this. Still you need this 500.
Yeah.
Exactly.
This 500 should be there.
Okay.
So in that case, you have how many population? Five different population. No, 4 is this.
4 actually.
Plus this one.
Exactly.
Plus this one is 5. So when I put this one aside, I am just removing that one. I'm looking at population at the beginning. We started with 500. Okay? If we put 500 here, then we have 500 here, 500 here, 500 here, 500 here. We also have 500. So if you divide that one by 5, you are still taking away, you are left with this 500. That's what I'm doing here. So look at it at population at the beginning and population at the end. From that angle. Neonatal mortality. Again, this is life death before 1 month. This is death before 1 month. How many was there? 43, isn't it? 43 divided by how many population we have there? 43 died in the first 4 weeks of life. 384, 387 life calves were born. So 387. This is our denominator. So again, all this is more like a cumulative. Those that died in the first 2 weeks of life are also included in this one, because this is death during the month. So the first week, even the first days, like pre-partum basis, or those that in the first two days, they are still included in this, in the death in the first month or neonatal mortality. So death in the first month include all deaths that occur from that live birth death. Case fatality is there, 15 died, so it is just 15 divided by 45. Case fatality rates. Death is from what? From a given disease. Proportional mortality rate for blood. Again, this one, I don't know how you guys look at it, but it is comparing only death in the breeding age females. So there are 15 deaths from blood. In total, there are 30 deaths. Again, during the year, 30 cows died during the year. So blood, death from blood is included in that one. 30 cows died during the year. That's what information says. 30 cows died during the year. So the death from blood is included in this. The other question is the crude mortality during the year. Again, this depends the way you look at it. So I know some student who came and saw me, they tried to include mortality from calf mortality as well. That's fine, but yeah.
It can't possibly just be 30 deaths throughout the year because there was 43 deaths that were from 4-week-old calves. So
Pardon?
there was 43 deaths from 4-week-old neonates. So that's more than the 30. So it had to be about 73
plus
deaths.
30. Yeah.
43.
Proportional.
No.
Proportional.
G, the proportional.
Mortality rate
Yes.
for blood. So you want to include this one there?
Because it's the total
It's
deaths.
That's
Totals
fine,
that
that's fine.
died.
I have no
75.
problem with
43
that.
plus
But
30.
as I said, for the calves, really mortality was not defined. The cause of death was not mentioned. So if it is blood or somebody, we really don't know that one. Okay?
But I thought like the denominator.
It's fine, I have no problem with
Yes.
that. Yeah, it's fine,
75.
yeah. That's fine, I have no problem with that. But as I said, if you look at the data, you can see that mortality was only mentioned from blood was only mentioned for breeding age female. So even if you do it for breeding age female, then that is still correct. That's all I'm saying.
Thank you.
Similarly, accrued mortality during the year, if you include calves, that's fine. But again, for the calves, the mortality is not complete. So if you only did for breeding age cows, that is also fine. If you see here, 387 live calves were born during the year of it, 29 died before 2 weeks of age, and a total of 43 died during the first week of life. So we don't know what happened after that for the whole 1 year period. So as a result, the information is not complete for the calf. So for me now, I just deal with breeding age female because that is more complete. But if you still treat this one as the whole population, because we are talking about crude mortality, that is also fine. That's fine. So in that case, if you are including calves, then you already have what? Population for breeding age female, then you just include a number of calves. Pregnancy rate, and again, is what is the data for pregnancy rate? 540 cows and heifers were bred, of which 37 were never found pregnant. So that is your pregnancy rate. 503 divided by 540. 503 divided by 540. 503 has been divided by 540. So that is the pregnancy rate. Any questions? Yep. What, crude mortality? Yeah. If you look at the completeness of the data, we have complete data for breeding age females because it says 3 cows died during the year. Okay? So if we just calculate crude mortality for the breeding age females, that's fine. Okay? But it says crude, so if you also want to include mortality in the calves, that is also okay. But as I said, mortality in the calf is really not complete.
What about 15 that died as a result of the blood infection?
Pardon? I can't hear you.
The 15 that died from blood infection.
15, that is included in the 30. 30 cows died during the year. So from those 30, 15 died from blood. So that includes the death from blood. Does it make sense? Look here, it says 30 cows died during the year. So this is the key. Okay? Whatever death that occurred, whatever cause of death that you have is included in this one. So 15 below are what among these 30? Clear now? Any more questions?
Dr. Babo?
Yes?
Okay, can you come to the board and explain the average population thing?
With
Because when we went over it last time, the average population formula was different from what you just did this time. And I'm just confused.
It's really not different. I talked about this the same way the other day. I said you can use those initial figures whenever you have those changes in the population. Here you have 500 from the beginning, okay?
Right.
You can continue until plus 590,
Yeah, this is the best way.
okay, plus 528, minus, what's 500 minus 65 is 535.
Yes.
Okay, you can have them this way and divide everything by
By
this number. Not 4, probably 5.
If you do that, you get a different number.
Yeah, it's different, yes, because that's what I'm saying. It's a little bit different, but not really that big deal. It does not really make a real difference. That's what I'm saying. Because in this case, what you are really more accurate because you are looking at each change. That one is cumulative. Beginning, start at the beginning and you go at the end. You know what I'm saying?
Okay.
So if you want to be more accurate, and if you know each one is, those changes when the time has been identified, the best way is to do incidence density, really. These ones are just really average point or average proportion. So each time, you try to be more accurate, then you get a little bit different data. But it's really in decimals. When you finally calculate it, it's in decimals, so it's really not a big deal.
Okay, I guess that makes sense, but like for a multiple choice exam, like how is that going to impact, like how would we do it for that kind of situation if you're getting different numbers?
I think the best way is, for me, again, what I advise, because we are talking about cumulative, the best way is look at population at the beginning and look at the population at the end.
Okay, so we should do it the first way.
The first way, yes. That's the way I see
so
it.
you want us to see what we have at